Hello, class. We'll continue the recorded lectures for section 4.4, which is solving trig equations for angles of theta. And the idea of calculating all possible angles that will fulfill the equation and make it true. And again, the idea of period. Remember, cosine and sine have a period of 2 pi, and tangent has a period of pi. So when we do these calculations, the right answer or the correct angle is going to occur every 2 pi times for sine and cosine, and every pi time for tangent. So let's do a couple more examples. First one I want to do is one to realize, just like in algebra, sometimes we might not get an answer, meaning there are no solutions. And so say like you get an equation that looks like this: 1/2 cosine of theta equals 1. So you bring the 1/2 to the other side. So you multiply each side by 2, and you would get cosine of theta equals 2. So what angle will make this true? Well, can cosine be ever greater than 1, right? And the answer is no. So here there would be no solution. And so you do have to realize that if you have sine or cosine, right? If the number is greater than 1 or less than -1, there's going to be no solution. Because if you remember the graph, right, our amplitude is 1 for both sine and cosine. Tangent's a little bit different, right? Because it goes plus or minus infinity. But you'll see that sine and cosine, it's very important to realize that there are solution sets that do not exist, right? Or there are no solutions. And here is the example of that. Okay, let's do another one. And let's see, which one do I want to do here? Here we go. Let's do this one. So this would be tangent tangent squared of theta minus 3 equals 0. So let's do a little bit of algebra. We'll bring the minus 3 to the other side. So you add 3 to both sides. So how do we get rid of the square? Well, you remember back in algebra, we had x squared equals 3. So when we got rid of the squared, what you did is you multiplied each side by or you took each side to the 1/2 power, which is doing the square root, right? But remember, when we did the square root, there's a plus or minus involved with that. So this answer would be x equals plus or minus square root of 3. Because remember, minus square root of 3 times minus square root of 3, the two minuses cancel and you get plus. So you always will get two solutions. So when we do the algebra on this side, we do the exact same thing. So we take the square root of both sides. So this would be square root of tan, and that would be plus or minus the square root of 3. So this would be tan of theta equals plus the square root of 3 or minus the square root of 3. And so one of the things now is we're going to get two solutions, right? So if you looked on our sheet, plus the square root of 3 would be 60 degrees. And that would be pi over 3 in radians. So what would be minus the square root of 3? Well, if you think about it, and we're doing that calculation, we typically, when we talk about minus, remember that tan inverse is defined on minus pi over 2 and pi over 2. So the logical answer would be an angle in quadrant 4. And so in that case, what would be the angle in quadrant 4? It would be minus 60 degrees. So in this case, when we're indicating this angle, we could indicate it as minus 60 degrees or minus pi over 3. And the reason why we're indicating it minus is that the tan inverse is defined from minus pi over 2 to pi over 2. So in quadrant 1 and quadrant 4. So when we indicate this as a solution set, we need to take into account the period. So one solution for theta would be pi over 3 plus n pi. And then another one that would work would be minus pi over 3 plus n pi. And again, n is any integer. Spelled integer wrong, I think. There we go. So just another example, as you can see, we could add some more algebra and make it a little bit more complicated. And that's what we're going to do next, of course, is to make it even a little bit more complicated. And so here was the problem we did that you would see in the book as well, or in the PowerPoint. And again, we're indicating this because the tan inverse is defined in quadrants 1 and 4. So what we're going to talk about now is solving trig equations now by factoring. Again, I've used this term enough. We've got algebra on steroids again. And sometimes this gets a little bit complicated until you kind of get used to it. So let's walk through this example here. We have sine square root of x minus 2 sine of x equals 3. Okay, and so let me write this one up here. Instead of using x, I'm going to use theta. I like to use theta for the angles in these calculations, but you'll see I don't have any control on what variables WebAssign uses, so, or the book. So pretend like we're back in our college algebra and we have this equation, x squared minus 2x equals 3. So how did we solve for quadratics? Well, the idea for solving quadratics was you brought all the variables to one side of the equal sign and you set it equal to 0, and you actually solve for the roots of the equation, as they were called. So we'll bring the 3 other side. So there was a variety of different ways to solve this. One, and the most important way, was the quadratic formula, right? And you could plug it in the quadratic formula and get the 2 roots. They could be real, they could be complex. The other way was the factor. And the third way we talked about is completing the square. And in this section, I believe that we will be focusing on factorization. And so when you do the factoring here, there's a variety of ways of factoring. Check out some YouTube ideas. I'll give you what works for me. As I look for what 2 numbers that you multiply by the constant term, that when you add them together, you get the b term, right? Or minus 2. So when you set this up, one has to be a minus and one has to be a plus, because when you multiply those together, you'll get a minus. And so the minus 3 has to be 1, and we have plus 1 equals the other. So these two will give us minus 3, and then minus 3x plus x gives us minus 2. So how do we do that in the trig world here? Well, to do that in the trig world, what we're going to do now is, give me a sec here to finish that, is think about how we would split this up. Well, we do the exact same thing. First thing we want to do is bring the 3 to the other side and set it equal to 0. And we're in a math class, so this is strategically set up. I like to get rid of the signs and put in x's so I could see the factorization easier. Some of you might be able to do it in your head, but I like to do this. Set x equals sine squared of theta, or excuse me, sine of theta, and you'd see we end up with x squared minus 2x minus 3. And I see that that factorization, which we just did, looks like x minus 3, and then x plus 1. So then what I like to do is plug sine back in and then finish the, so this would be sine of theta minus 3, and then this would be sine of theta plus 1, and that would equal 0. And so now you remember how we solve for quadratics, right? Is that each one of those factors that are multiplied together, if they equal 0, it's going to solve the equation, right? 0 times any number is 0, and vice versa. So we have two equations that we're going to solve for. And the first one would be sine of theta minus 3 equals 0. And then we have sine of theta equals 3. Remember we talked about, is there possible solutions? This one does not, right? 3 is greater than 1. So this has no solution. So this factor, there's no value of theta that you can plug in here to get a 0. So that won't be able to solve it. So what about the next one? Sine of theta plus 1 equals 0. So this would be sine of theta equals minus 1. Minus 1 is okay. So where does minus 1 occur? Well, if you think about our graph, right? Sine of 1 is 0. Or, sine of 1 is theta equals 0. I'm sorry, this is 0. This is 1. Remember, it's the y value. I got myself confused, right? So this would be sine of 0 here and 0 here. And this would be 1, and this would be minus 1. So if you think about that, that would be 270 degrees, or 3 pi over 2. And so when we do all values, right, we would do theta equals 3 pi over 2. And then the period of pi, or sine, is 2 pi. So that would be 2 pi and n. So that would be the solution set for this equation up here. So you can see we're going to make it a little bit more complicated as we continue. We will, chapters 4.5 is going to bring everything together. Section 4.5 is going to bring everything together, including this. So I'm going to stop the recorded lecture, and I'm going to continue and probably finish section 4.3 in the next lecture, going through a couple more examples that, again, get a little bit more complicated.